Solutions for quiz 6 for math 111. The first problem, we're given a function, a quadratic polynomial, and asked to express it in this thing that I'm calling transformation form. Basically make it look like this. So the way you do that essentially comes down to completing the square. So I'm going to have to do a lot of algebra and kind of mess with both sides. I don't want to view this as a function. I think it would be easier if I could view it as an equation. So I'm just going to rewrite this. This might seem like a pointless step. Maybe it is. It's instead of f of x equals, I'm going to make it y equals, just so it looks more familiar in terms of an equation. At any rate, completing the square. In this class, I tell you that when you're trying to complete the square, you have to first get stuff in a specific form. And that form is, you want your x squared and your x terms on one side of the equation all by themselves. So I subtracted 1 from both sides here. But you also want your leading coefficient, the coefficient on your x squared term, to be a 1. So right now it's a 2. If I want to make it a 1, I could divide both sides of the equation by 2. And get down here to this step. And then the trick from here is we almost have a perfect square on the right-hand side of the equation here. If there was just an extra number out here, I would have a perfect square, which is what I want, so it'll start to look more like this. Now that number that is missing is a 4. The reason it is a 4 is because half of the coefficient on the x term is a 2, and 2 squared is 4. So I need a 4 over there, so I'm going to add 4 to both sides of the equation. And what I've now managed to do is create a perfect square over here on the right-hand side. So I'll leave the left alone, y minus 1 divided by 2 plus 4. You might wonder, could you simplify that? Could you get a common denominator? You could. I'm not going to bother. I'm just going to end up undoing stuff when I solve for y later, so I'm just going to leave it a mess like that. And on the right-hand side, you might recognize that this is x plus 2 squared. If you guess that this is x plus 2 squared, you could expand this binomial, aka FOIL, and get back to here. Probably an easier way is to note that if we do things in the form that we just did, you will always have a perfect square over here, and furthermore, it will always be x plus half of the coefficient on x in this step. So x plus 2, which will be what's getting squared. At any rate, I now have something that looks close to this, except I no longer have a function. I have this equation with stuff on both sides. So if I can solve it for y, which I really am just using to take the place of f of x, I'd be done. So I'll subtract 4 from both sides of the equation. And then I will multiply both sides of the equation. Whoops, subtract 4 from both sides. Then I'll multiply both sides of the equation by 2. Note that when you're multiplying both sides of the equation by 2, you have 2 terms on this side of the equation. First one is this x plus 2 squared thing, so that's the 2 is hitting it there. And your other term is this 4, and you're subtracting the 2 terms. So 2 times 4 gives me 8. And then finally add 1 to both sides of the equation, and you get y equals, or maybe I'll write f of x equals 2x plus 2 squared minus 7, because negative 8 plus 1 will get me to negative 7. And what I now have is something that looks like this. It's awesome. Done with part A, 6 points. Why bother doing all that work, all that complicated algebra? Well, because it'll answer a lot of questions. It'll answer part B, for example, where you're asked to find the vertex of this parabola. Because you can view this as just transformations of our standard parabola, f of x equals x squared. This 2 right here has some sort of vertical stretch thing going on. This minus 7 is a vertical shift, and this plus 2 right here is a horizontal shift. But when we're talking about the vertex of the parabola, a vertical shift will not affect it, because essentially we're multiplying the y values by 2. And since the vertex starts out with the y value of 0, 0 times 2 or any other number is still 0. So the only things that will affect the vertex of the parabola is the number you have here and the number you have here. Maybe I'll say v equals. For the x-coordinate of the vertex, I'm only concerned with horizontal transformations. And so my only horizontal transformation is this plus 2. I'm affecting the x value here. And you might think that a plus 2 would increase your x-coordinate by 2, but it doesn't. It decreases it by 2. So it started out at 0 in my standard parabola, and now it's at negative 2. And for my y-coordinate, as I already said, this 2 does not affect the y-coordinate of the vertex, because it multiplies 0 times 2, which is still 0. But subtracting 7 from the y-coordinate will affect the y-coordinate of the vertex. And so it started out at 0, it stayed at 0, it went down to -7. The vertex of this parabola is -2, -7. If you happen to have the fact that the x-coordinate of the vertex is always -b over 2a, when you define a, b, and c to be the coefficients on the x squared, x, and the constant term, respectively, -b would be -8 divided by 2 times 2, which is 4. -8 divided by 4 is -2. Looks like that checks out down here. Use your answer to part A to find the x-intercepts of the parabola. Okay, so for the x-intercepts of the parabola, you want to know what values of x will make the height, the f of x value, equal 0. So essentially you're just solving an equation here. We know what f of x is, it's given to us up here, so you could set this thing equal to 0 and solve. But since you've already done all this work to complete the square, and it even says in the problem, use your answer to part A, it's easier to use this form of f of x. So I'll say I know that f of x is 2 times x plus 2 squared. And so if I could solve for the x value that would make this entire f of x thing equal to 0, I'd get my x-intercepts. Essentially solve this equation right here. Add 7 to both sides. Divide both sides by 2. Take the square root of both sides of the equation. Make sure that you remember that when you take the square root of both sides, you always have to put in that plus or minus. And then finally subtract 2 from both sides. Maybe I'll come over here. I get that x equals -2 plus or minus the square root of 7/2. You could rationalize the denominator here if you felt like it, but I don't really care that you do, so I'm going to leave the answer just like this and say that these are the x-coordinates of my x-intercept. So I don't know, as for the x-intercept, you might want to say this, comma, 0, -2 plus the square root of 7/2, comma, 0, -2 minus the square root of 7/2, comma, 0. But instead of writing that, I'm just going to say it and leave my answer like this. Okay, moving on. Determine the y-intercept of this parabola. You'll note that in parts B and C, I said use your answer to part A to find. Part D, I did not say that, because while you could get your y-intercept from this form, it's easier to get your y-intercept from this form, because the y-intercept just happens at f of 0. The y-intercept is just the spot on your graph where the x-coordinate, the left and right, is equal to 0. So to figure that out, you just got to figure out what comes out of this machine when you put 0 into the machine. Take any form of your function, this one or this one, and change all the x's into zeros. Could do it here, but it's easier to do it here. Because if you change all these x's into zeros, you get 0 plus 0 plus 1. I'll just write f of 0 equals 1 and call 1 my answer. And again, you could write 0, comma 1. I guess I'll write that if you really felt like it. But I know what you mean when you say this, so I'll call that good enough. All right, new problem. We got a new polynomial here. Unlike up here where we had a quadratic polynomial, down here it's going to turn out I have a 6th degree polynomial. I didn't want you to have to factor a 6th degree polynomial. We don't really have the machinery yet to be able to do that, although we'll be able to at some point. But right now we really don't. So instead I give it to you in the factored form. I give it to you like this. I ask you lots of questions. First one is determine all x-intercepts of this polynomial. Much like up here, the way you find the x-intercepts is you figure out what values of x will make f of x, the height, equal to 0. G of x in this case equals 0 is equivalent to just solving this equation. And the nice thing about this equation is I just have a bunch of stuff multiplied together. -1/8 times x minus 1 cubed times 3x plus 2 squared times x plus 4. And when I multiply those 4 things together, I get 0. And this nice property of 0, or really multiplication in 0, says that the only way you can multiply together numbers and get 0 is if one of those numbers is 0. So either this thing here is 0, this here is 0, this here is 0, or I guess this here is 0. But this isn't 0, this is -1/8. So I don't have to worry about that, but this might be 0. I have to figure out when x minus 1 cubed equals 0, or maybe 3x plus 2 squared equals 0, or x plus 4 equals 0. And I can solve all of these. I guess in this case, if you want to get rid of this cubed, you can take the cubed root of both sides of the equation and get x minus 1 equals 0 because the cubed root of 0 is just 0. And then if you add 1 to both sides of that equation, you get x equals 1. Over here, you subtract 2 from both sides of the equation and then divide by 3, and you get x equals negative 2/3. And over here, you subtract 4 from both sides of the equation and get x equals negative 4. What you've just come up with are the 3 x-intercepts, wish I'd given you more room, of this polynomial. Determine the end behavior of this polynomial. So for end behavior, you care about two things. You care about the degree of the polynomial and the leading coefficient. End behavior is actually a little bit easier if I give you a polynomial in this form as opposed to in its factored form like we have down here. But the x-intercepts are so much harder if you give it the polynomial in the expanded form. It's worth doing a little bit of extra work here as opposed to doing a lot of extra work up here. So the way we can figure out the end behavior is we need to know the leading coefficient, and what that means is if you were to expand this whole thing out, do 3x plus 2 squared, FOIL it all out, multiply by x plus 4, figure out what x minus 1 cubed is, spend forever algebraically figuring that whole thing and then taking the negative 1/8 and distributing it to all the terms, what would your leading coefficient be? Well, the answer is you could figure out what that leading coefficient would be. I think in this case it would be negative 9 divided by 8. But really I don't care what the number is, I just care that it's negative. So the leading coefficient is negative. The reason I know it's negative is if you do x minus 1 cubed, the leading coefficient there will be a positive number because it'll come from just x times x times x. It'll end up being x cubed. Same idea here and here. However, when I take this negative 1/8 and distribute it through, that'll change the positive into a negative. I get that my leading coefficient is a negative number. The degree of the polynomial, again, if I gave you the expanded form, it'd be easier to tell what the degree of the polynomial is. In this factored form, we have to think about it a little bit. I kind of get an x cubed out of here and an x squared out of here. So when I multiply all those together, I get x to the 5th. And multiply by this x, I'm going to get x to the 6th. The degree of the polynomial is even. Specifically, it's 6. But I don't care that it's 6. All I care is that it is even. And so when you're trying to figure out the end behavior, you only need to know two things, whether the leading coefficient is negative or positive, and whether the degree of the polynomial is even or odd. If the degree of the polynomial is even, that means that as x goes towards infinity and as x goes towards negative infinity, the same thing is going to happen. So what I'm saying is I can kind of think of my answers as what I write here and what I write here. What happens to the height of this polynomial, the y-coordinate, as x goes to infinity and towards negative infinity, when I go way to the right on the graph and way to the left on the graph? And because the degree of the polynomial is even, it's going to do the same thing. These answers are going to be the same. So then the question becomes, are they going to be positive infinity or negative infinity? They're going to be negative infinity, and I know that because the leading coefficient is a negative number. So as x goes towards infinity, y goes towards negative infinity. As x goes towards negative infinity, y goes towards negative infinity. This right here describes the end behavior of this polynomial. So it's the answer to part B. Okay, part C. Part C, much like part D down here, is to determine the y-intercept of the parabola. Here I figured that out just by changing all the x's into 0 and figuring out the y, the output. Same idea down here. All I got to do is figure out g of 0, which is going to be negative 1/8 times negative 1 to the 3rd power. This negative 1 came from 0 minus 1, negative 1, and then it gets cubed. If I make this x 0, I get 3 times 0 is 0 plus 2. It's just 2. But then don't forget it's being squared. And then 0 plus 4 is 4. I get whatever this thing is. Let's see, negative 1 cubed is negative 1. 2 squared is 4, so I get negative 4 times 4 is negative 16. Negative 16 divided by, or maybe times negative 1/8, gives me negative 16 divided by negative 8, which just equals 2. Y-intercept of this polynomial is 2. Now it's saying, okay, you did all that work, draw me a picture. can do that. The y-intercept is at 2, meaning it's going to go through that point right there. The end behavior, when x goes towards infinity, y goes to negative infinity. When x goes to negative infinity, y goes to negative infinity. What that means is the arrows are going to point down in both directions. X-intercepts, I got an x-intercept at 1. There's 1. I got an x-intercept at negative 2/3, somewhere in there. And I got an x-intercept at negative 4. So you might be like, okay, nice, just kind of draw lines going through all those dots. Well, you got to be a little bit careful. The multiplicity of this root is even. What I mean by that is this negative 2/3 comes from this factor, and the degree of that factor is 2. The degree of this factor is 1, and the degree of this factor is 3. When the degree of the factor is odd, nothing strange happens. But when the degree of the factor is even, the graph you can kind of think of is it's going to bounce off the x-axis at that point. So really what I'm saying is I want the graph to go through the x-axis at x equals 1 and x equals negative 4, but I want it to bounce off in some sense at negative 2/3. So I'm going to start way down here because remember my end behavior told me that way to the left of the graph I'm going to be going down. And whoop, I want my graph to come up like this, go through this point. I don't know where it turns around there, which is why this is just an approximate graph, although once you get to calculus, you'll be able to figure out exactly where it turns around. We're going to come down here, we're going to hit this point, but we're going to kind of bounce off and change directions, which is a good thing because I had to get through 2 here in order for my y-intercept to be correct. And I got to make sure I get, well, that went a little bit too much. Let's try that again. It's harder to draw on a computer than you would think. Harder for me anyways. Good enough. And then I want the arrow to keep going down in this direction because, again, remember my end behavior tells me I'm going to go down on either side. Here's a very, 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 very approximate graph of this parabola. I'm not happy with it. I'm going to do it one last time. Although maybe by now you're thinking you're good and you just want to be done with this video. It's fine too. Whatever. There's a very approximate graph of this parabola, which is the last thing you had to do on this quiz. So as long as you go through all of these 4 points that are labeled, you got your arrows going down in both directions, and you exhibit the proper behavior at each of the x-intercepts. Namely, you bounce off the graph right here, but go through the graph here and here. You're good. That's everything I want. So I will end this video here.